Welcome back, guys. One short video for you to understand the domain and range of a function in detail. Let's proceed ahead by taking the same graph that we had taken in the previous tutorial. If you want to go into some details, you can simply refer that previous tutorial where the set of values were given to you. The case was about the ball thrown vertically upwards. Okay, so domain and range of a function are basically determined by reading the x-axis and y-axis respectively. That means domain is read by reading the x-axis of the graph, and range is determined by reading the y-axis of the graph. So let's first of all read the x-axis of this graph. This is the point from where the journey is beginning. The ball is thrown vertically upwards, so the time recorded was 0 seconds. And at this point, the journey ends. The ball hits the ground and the time recorded was x is equal to 6 seconds. So basically, the value of x is between 0 and 6, of course, including the two extremities. So that becomes your domain, that the value of x ranging from 0 to 6. And in a broader way, we can define the domain as the set of all the possible x values. Similarly, if we go ahead and try to read the y-axis, it shows us the height that the ball will attain in this entire event, and it is attaining the maximum height of 45 from 0 meters, which can be represented in this way: the value of y from 0 less than equal to y less than equal to 45, which is your range of the given function. And in a broader way, we can say that the range is the set of all the possible y values of a function. So this is the case, and that's how you are able to find out the domain and range of the function. One more thing that you need to understand is natural domain, that you will come across in certain examples. That when there are no restrictions, then the domain basically is determined as all the possible x values that can be validly substituted into an equation. That means in our previous case, if we go once again here, you can see that the graph is bounded at these 2 points, means the event is starting here, the event is ending here. So basically our domain has the two endpoints, that is 0 and 6. Nothing is happening before 0, nothing is happening after 6. But in certain cases, the possibilities of x values will be more or perennial. So we have to see that, and those domains are termed as natural domains. Let's try to understand this fact by taking one example into consideration. Let's see, the equation is given as y is equal to 1 upon x minus 2. Now, as I said, the x given here, if you put any value of x, put it 1, 2, 3, 4, 5, 6, any value, negative, positive, integer, you will be getting some value of y. But if you put the value of x is equal to 2, I am afraid you will get this kind of equation, y is equal to 1 upon 0, which is undefined yet. So we can say that x has all the possible values, in this case except 2, because if you put 2, the equation becomes undefined. So in a broader way, the domain of this given equation can be written as x has all the possible values of r, that is the real numbers, except 2. That becomes your natural domain. Let's try to understand this thing further by taking one more example, this time of a square root. And once again, you can, in this case, cannot put the value 1 or less than 2, because if you do that, the square root will become negative, which is once again not possible. So your x has to be either equal to or greater than the value of 2 to get some value of y. So which is once again written in a broader way as the domain of x in this case is given by all the possible r values, but the values should be greater than or equal to 2. Okay, so this is the natural domain that you need to understand here, and that's it for today. We shall be meeting again, and now taking the chapter into more depth and understanding the quadratic functions and the solutions related to that. So till then, take care of yourself. Wish you all the best with the learning, and please do not forget to subscribe to our channel if you like the video. Thank you.